So let's say we have an equation for a parabola, like perhaps y equals, I don't know, x plus 5 and x minus 2. And I said, can you tell me what those x-intercepts are? You would say, sure, not a problem. The x-intercepts occur when y equals 0, so we're going to have that as our equation, and the principle of zero products tells me that when two numbers multiply and make 0, then one or both have to be 0. So I'm going to set the equation. I'm going to write x plus 5 could be 0, and x minus 2 could be 0, and then I solve those equations. Subtract 5 from both sides, add 2 to both sides. I get x equals either negative 5 or x equals positive 2. And if I wanted to graph this parabola, I would be really close to doing it. I'd have an x-intercept here at 2 and one at negative 5. 1, 2, 3, 4, negative 5, like that. X-intercepts are important because they tell us all kinds of things. If we are thinking about a projectile being shot into the air and landing somewhere, well, our x-intercepts tell us where that projectile was launched and where it lands. So we really care about that. Of course, if this was a parabola facing down, we would be negative. Okay, let's see here. Let's try another problem. Let's say we have something like this. Y equals 2x plus 3 times x minus 4. Could you tell me the x-intercepts of this parabola? Could you solve this equation? Sure you could. You would tell me, no problem. You would say, I have a product, numbers that multiply to make 0, and that means that either 2x plus 3 is equal to 0 or x minus 4 is equal to 0. And I solve for both. Subtract 3 from both sides. 2x equals negative 3. Divide by 2. X equals negative 3 over 2. Or add 4 to both sides. X equals 4. These are both of the x-intercepts of the parabola. Let's do another example. Let's say our equation is this: y equals x squared plus 8x plus 15. Ooh. Now, we don't have it factored, so we must first factor it, but no problem. You guys know how to do this. Remember, we set up our box. We have x squared here, we have 15 here. We're trying to figure out what numbers we are going to go in this box here and this box here. And so we can set up that diamond box factoring problem. We can say, what multiplies to 15 and adds to make 8? 3 and 5. 3 times 5 is 15. 3 times 5 is 8. So we can say, well, this will be 3x and this will be 5x. And then you can factor out your common factors. X, 3, positive 3, x, and positive 5. And so now my factors are x plus 3 and x plus 5 is equal to y. But if the question is, what are the the x-intercepts, then you would set y equal to 0. And since you have a product, two things multiplied together to make 0, one or both of them are 0, so we'll figure that out. X plus 3 equals 0. Or x plus 5 equals 0, and we solve both. Subtract 3, x equals negative 3. Subtract 5, x could be negative 5. And so our answers are, the x-intercepts are -3 or -5 and -5 even, both of them.